All right, we're looking at trig in any quadrant, and this is just another way to look at trig on the unit circle. So first we looked at trigonometry using our special right triangles, and now we're going to look at it just like with traditional opposite over adjacent, hypotenuse over adjacent, and so on and so forth. Okay, so I started by drawing us a figure, and we have if I have an angle with the terminal side in the first quadrant here, I have, and my angle is open to theta, then the opposite side is the side that is going up. The adjacent is the side on the x-axis, and the hypotenuse is the radius. Our ratios are sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent of theta is opposite over adjacent. Then remember what the relationship between sine and cosecant is. They are reciprocals, so we're going to get the hypotenuse over the opposite. Secant is the hypotenuse over the adjacent, and cotangent is the adjacent over the opposite. Here's an example of finding all 6 trig functions, trig ratios of the given angle. So we know that negative 3, 4 is on the terminal side of our angle. So I'm going to go ahead and start by drawing our initial side. And then I'm going to move over 1, 2, 3, up 1, 2, 3, 4. So the terminal side lays at the point negative 3, comma 4. My angle theta is here, but I have my reference triangle that helps me use my right triangle trig. So the side on the x is negative 3, the y is 4, and then my r value is we can use Pythagorean theorem. So x squared plus y squared is equal to r squared. So I get negative 3 squared plus 4 squared is equal to r squared. So I get 9 plus 16 is equal to r squared. I combine those to give me 25 is equal to r squared. And then, of course, we square root. So r is equal to 5. Our radius is always positive. Always positive. Now that I have the sides of my triangle, I can see what my trig ratios are. So the sine is the opposite over the hypotenuse, which would be 4 over 5. Okay. The cosine is the adjacent over the hypotenuse. Let's see, this is my opposite, my adjacent, and my hypotenuse. Okay, so we get negative 3 over 5. Makes sense for cosine to be negative because my terminal point is in the second quadrant. Tangent is rise over run, or opposite over adjacent. So we get 4 over negative 3. And then the cosecant, secant, and cotangent are the reciprocals. So I get 5 over 4, 5 over negative 3, and negative 3 over 4. We're going to go ahead and evaluate sine of 45. So I use, sine of pi over 4, which is the same thing as sine of 45. So just let's sketch in our triangle. Okay, terminal side. Theta is equal to pi over 4. My radius is 1. So when I have a radius of 1, I have side lengths of root 2 over 2 and root 2 over 2. So I know that the sine is equal to the opposite over the hypotenuse, which would be root 2 over 2 over 1, which is just root 2 over 2 in the first quadrant. So my sine ratio is going to be positive. Let's see. So the cosine of 5 pi over 3, where's 5 pi over 3? It's going to be it's more than 1, but less than 2. So I can see that I'm doubling my denominator and subtracting 1 to get my numerator. So this must be in the fourth quadrant. So I'm going to count, let's see, 5 pi over 3 would be, it's a third, so it's closer to the y-axis. I'm going to go ahead and draw my reference triangle, which connects back to the x-axis. So these side lengths would be 1, 1/2, and √3 over 2. The interior angle of the reference triangle is pi over 3, which is 60. So the cosine would relate to the adjacent over the hypotenuse. My adjacent is 1/2. My hypotenuse is 1, so the ratio is just 1/2. All right. A surveyor is studying 50 feet, is standing. I don't know why is it studying? Standing 50 feet from the base of a large tree. The angle of elevation to the top of the tree is 71.5 degrees. How tall is the tree? So let's first start by changing our calculators into degrees. Okay. Second, let's draw a diagram. So I'm the surveyor. You're standing 50 feet from the base of the tree. And an angle of elevation is looking up, okay, by 71.5 degrees. And we also know, nope, we don't know anything else. We need to know how big this tree is. Tree. Happy tree. Okay. So we can use our, assuming the tree is standing straight up, we can use our right triangle trig. So which ratio would you use? Using to find the height of the tree when you have an adjacent side, I'm going to use the tangent. The tangent of 71.5 degrees is equal to the height over 50. So this is the opposite of me, and the adjacent to me, and the hypotenuse to me. Okay, so 50 tangent 71.5 degrees is equal to the height. So that gives me, I'm going to change my calculator to degrees. Tangent 71.5 times 50. Yeah, the height of the tree is 149.434 feet. And that is it for this lesson.